Here we have a problem that requires the manipulation of fractions, and as usual we will first convert those mixed numbers to improper fractions. So before going into the manipulation of the fractions, let us convert the mixed numbers to improper fractions. There we have 3 and 1/5, and it is important to take note of the different parts of the mixed number. We have the whole number, we also have the numerator and the denominator. Multiply the denominator by the whole number, then add the result to the numerator. 5 3s 15 plus 1 is equal to 16. So we have the first part, that is 5 multiplied by 3 is equal to 15. We add 1 to that and we get 16. So that value will be the numerator of the improper fraction, and the denominator will be the same denominator as we have right there in our initial fraction. We will do the same here again. We have 5 2s 10, multiplying the denominator by the whole number, then we'll add the numerator to that, and then we have what? 10 plus 4 is equal to 14. That will be the numerator of the improper fraction, and then we have the denominator will be the same. Now we will go through the process of actually solving the problem. In solving this problem, we need to simplify this expression, and the answer that we will get should be written as a fraction in its lowest terms. Rewrite the expression with the improper fractions obtained on the previous slide. That is what we are doing. And we replace 3 and 1/5 by its equivalent, and the denominator of this large fraction we do the same. What have we done here? We have enclosed the upper set of fractions, this, in brackets, and replaced the large fraction bar with a division sign. So this large fraction bar is replaced with a division sign. Of course, we know that the fraction bar and the division sign are equivalent symbols in mathematics. Addition of fractions with denominators that do not have common factors may be done by making use of the following mechanics. The denominator is the product of the two denominators. So in this mechanics that we are doing, we are just making use of the fact that whenever we add fractions and the denominators do not have common factors, we can make use of a simple process that can expedite the entire solution. So in so doing, we say that 5 3s 15, and that will be the denominator of the answer. Then what do we do? Of course, that is merely multiplying the two denominators. Then multiply those two numbers. 3 times 16 is equal to 48. Then we have 2 times 5 is equal to 10. Right. And we are not taking it for granted that students will just take a process like this and use it all the time without knowing the reason why this can always be done. On the next slide, we will demonstrate why this process always gives the correct result. Division by a fraction is equivalent to multiplication by its reciprocal. We cannot leave this out in our expression, so in the next step we will just make use of the fact that when we are dividing by a fraction or even a whole number, it is the same as multiplying by the reciprocal. In the next step, we will have 48 minus 10, which is 38, and at the same time, we will reduce the fraction by a common factor of 5. So 5 into 15 is 3, and 5 into 5 is 1. 48 minus 10 is equal to 38. So 38, the result of subtraction, then we have reducing by a common factor of 5. We have 5 into 5 is 1, 5 into 15 is 3, and the 14 will no doubt be returned exactly as it is. There may then be a further reduction by a common factor of 2. We are seeing that 2 is a common factor in the numerator and the denominator. Therefore, we may go ahead and reduce by a common factor of 2. 38 divided by 2 is 19, and 14 divided by 2 is 7. Finally, we will say 19 multiplied by 1 is 19, and 3 sevens, 21. The result is 19 over 21. According to our assertion on the previous slide, let us take two general fractions and add them. We will choose fractions whose denominators do not have common factors. So there we have our two fractions and we are adding them. And we will go back to the principles that we have learned in primary school and see what happens. With no common factor, the common denominator will be the product of the two denominators. So we have b multiplied by d is bd. That is our common denominator. The common denominator is always the lowest common multiple. But in this particular case, because the denominators do not have a common factor, then we are sure that the lowest common multiple of those two numbers will be the product of the two numbers. We will then say b into bd gives d, or we may say bd, because we normally say b into bd, and that's d, then we take d and multiply by a. So we have this bd being divided by b, and the result is d. Then we'll take this d and multiply by a, we get ad, and this will be the first term in the numerator. Also, we will say what? d into bd is b. Then we'll take the b, multiply by c, and we get bc. So bd, we are dividing that by d. The result is b. We use that b to multiply c, and we get bc, as the way that we were taught in primary school. The composition of the terms in the answer will reveal that the denominator is the product of the two denominators. So we have this resulting denominator is the product of the two denominators. Then what do we know? The first term in the numerator of the answer is the product of the first numerator and the second denominator. So we have, this is AD, which is A times D. So we are multiplying these two. And what do we know? The second term in the numerator of the answer is the product of the second numerator and the first denominator. So we have this BC is actually B times C. Or in the other way, C times B. It does not matter, because multiplication is commutative. I do not like when students are programmed to do things in mathematics. However, we should not have to reinvent the wheel. Notwithstanding, it is important to understand why things are done, and hence this presentation that we have on this slide. So it is not a matter of students just saying this is a process that I need to retain for no reason at all. Just to add two fractions, we just say BD, put that there, AD, put that there, BC, put that there. I'm not too much into students doing things for just doing sake. It is very important to me that students understand why things are done. And I imagine that if students understand exactly why this is done, there's no need to always have to go back to the finer details of what we do in primary school in order to solve a problem like this. We know that, and of course in this particular case we are trying out our mechanics that we took a look at on the previous slide. We are trying that out with two fractions. A half plus a quarter is equal to 3/4. So let us see if the procedure holds for the addition of fractions even though they have a common factor of 2 in the denominator. So notice that the denominator here is 2 and the one here is 4. These two denominators have a common factor of 2. What we did on the previous slide and also in the problem that was given to us to be solved is we manipulated situations in which the denominators did not have common factors. And we are saying that if the process is something that is correct or something that is generally applicable, then irrespective of the nature of the denominators, then we should get the correct answer. So we are choosing in this particular case denominators that have a common factor of 2. So let us do the same thing. The denominator of the answer will be 2 times 4, the product of the two denominators. That will give us 8. Then we say 1 multiplied by 4, and that is 4. Then we say 1 multiplied by 2, and that is 2. Finish up by adding the terms in the numerator. So add those numerators, 4 plus 2, 6 divided by 8. But we know the answer should be 3/4. There should be no difficulty seeing that the answer is still equal to 3/4. We may just reduce the fraction by a common factor of 2. That is all that is required. Reduce by a common factor of 2. We get our 3/4 right there. Irrespective of the relationship between the denominator of fractions, the procedure will give the correct answer. The only difference might be that the answer may or may not be in its simplest form. So we should get the correct answer irrespective of the relationship with the denominators. But especially when the denominators have common factors, the fraction that we get as our answer will not be in its simplest terms. I like to jump at the opportunity to follow the procedure when the denominators of the fractions are what I called exclusive. That is, they do not have common factors. If they are not exclusive, I always opt to use the LCM of the denominators. Jumping to use the method irrespective of the nature of the denominators may result in very large common denominators. Some might say, what the heck, when the fraction may be reduced at the end? I will say, just do the right thing. Find the common denominator by taking the LCM of the denominators. Now sometimes students will think of doing things as they say, the easy way. And I'm sure that they do not mind reducing fractions in the end. But if we opt to just multiply the denominators irrespective of their relationship we might end up with some denominators that are monstrous. Therefore, we should take the opportunity to find the LCM where necessary and make sure that our numbers do not in any way look outrageous. What are we about to do here? We are required to complete this table, and in the table we have the cost price, the selling price, and the percentage profit or loss that this selling price represents in relation to the cost price. What do we do? Percentage profit or loss. How are these related? The selling price is less than the cost price. It is therefore obvious that the sale represents a loss. So we are operating at a loss right here because the selling price is less than the cost price. And as a matter of fact, with some basic knowledge of mathematics, most of which can be from what we learn in primary school and a bit of common sense, then we should be able to get these answers correct. So of course we are operating at a loss, and we are stating it right there. In this first approach, because we are about to solve the problem but in more than one way, we are just using this approach now. Maybe next slide we will take other approaches. So in this first approach, let us write the selling price as a percentage of the cost price. The selling price as a percentage of the cost price by this, divide by this, multiply the result by 100, and we get 80%. This represents 80% of this. If this represents 80% of this, what do we know? The original is always 100%. The difference between them is 20%, and this represents the percentage loss. So the original is 100%, and if this represents 80%, then we are operating at a loss that is represented by the difference between the two percentages, and that difference is 20% as calculated right there, and that is our answer for the first cell of our table. For the second section, we may take the approach in which we find the percentage of the original that $100 represents. Since there is a profit of 25%, this represents the percentage by which the selling price exceeds the cost price. Now, according to what we have here, we have a profit of 25%. That means this amount, which is the selling price, is 25% greater than the cost price. Therefore, we are operating in the region of 125%, as we have it demonstrated here. Therefore, this amount, is the selling price, represents 125% of the cost price. Express the selling price as a percentage of the cost price. That is the approach that we are taking in this particular case. So this represents the percentage of the selling price. So this selling price, which is 100, divided by the cost price multiplied by 100, which is taking the percentage, then we know that is equal to 125. Here we said what? 44 over 55 times 100. Finding the percentage of the cost price that this $44 represent. What we are doing here is pretty much the same thing. Only that we have determined the percentage and we put it right here, and the cost price we do not know. Therefore, we may transpose this equation and find the cost price. So transpose the equation in order to find the cost price. By transposition, this is our first step. 125 times the cost price is equal to 10,000. And of course, since we are multiplying by 125 here, if we are transposing, then we will eliminate the 125 by division. Consequently, the other side will also be divided by 125. So if we divide both sides by 125, the 125 will be eliminated from this side. On the other side, we have 10,000 divided by 125, and that turns out to be $80. And that is our answer. In this second approach, let us find the difference between the cost price and the selling price, because what we are doing is attempting to find the percentage, and of course we have determined already that if in the first case it is a loss. We are attempting to find the percentage of the cost price that this represents. We are attempting to find out the percentage profit or loss that is represented by selling the article for $44 after buying it for $55. So 55 minus 44, and that is $11. Then we may just find the percentage of the cost price that this $11 represents. And that $11 represents a percentage of 20. Just as we have right here. A profit represents an increase, therefore there is an increase of 25%. So we have a 25% increase because that's a profit. There we go, increasing as it were by 25%. The original is always 100%, and we are increasing that by 25%. Therefore, we have 125%. This is the percentage of the cost price that the selling price represents. So we have 125% is the percentage of the selling price. The cost price is always 100%. That selling price, however, is $100. So that 125% is represented by $100. The original is 100%. So we have 125% and we need to find 100%. So we need to determine what 100% represents. But first, let us find what 1% represents by dividing by 125. So we have 125%, which is the percentage of the selling price. We need the cost price. The cost price is 100%. That is what we need to find. But let us first find what 1% represents. And that is easy. This is 125%. To find 1%, we divide by 125. The result we have right there. What do we do next? We have 1% and we need to determine 100%. All we need to do is take 1% and multiply that by 100. There's nothing to it. So find 100% by multiplying 1% by 100. So this is the result of 1% be multiplied by 100. And what do you know? Turns out to be the same thing as we had on the previous slide. So 1% to get 100, we multiply by 100. So converting 1% to 100%, multiply by 100. And also the equivalent of 1% is multiplied by 100. And let's see what the result is. So 100% is represented by $80. We will again take a look at the second section. My students are well accustomed to using this approach, and Demerol Smith always gets it right. Percentage of the cost price that the selling price represents is 125%. That was established already. A profit represents an increase, therefore there is a 25% increase. Like so. A percentage is a fraction with 100 as the denominator. 125 divided by 100 is equal to 1.25. This is the amount that we multiply by the cost price in order to arrive at the selling price. Because this represents the amount by which we multiply the cost price in order to get the selling price, because the percentage is 125. Therefore, the cost price multiplied by 1.25 is equal to the selling price, which is $100. So how do we find the cost price? If we are multiplying here, then in order to eliminate, we will divide both sides by 1.25, in which event the 1.25 will be eliminated from the left hand side, and on the right hand side we will have what? 100 divided by 1.25. So in order to find the cost price, we will divide the selling price by that amount, which is the amount by which we would normally multiply the cost price in order to get the selling price. Now that we have the selling price but do not have the cost price, then we divide the selling price by that amount in order to get the cost price. And as usual, that is $80. And we imagine that maybe some students are saying that this process is by no means shorter than any of the others that we have taken a look at. But with a certain level of understanding or maturity, which is the same level of understanding that students should have at this level, then most of this process will be mental. This seems like a lengthy process. However, most of the steps are done mentally in less than 5 seconds. And the only part of it that is written down is 100 divided by 1.25. So we do the rest of it mentally, and then all that we do is 100 divided by 1.25. Surely the examiners expect some candidates to be able to solve the problem in a single step. So mentally we will say 100 plus 25, that's not hard, 125 divided by 100, we get 1.25. That also is at the snap of a finger. So all we need to write down for the solution of that part of the problem is 100 divided by 1.25 is equal to $80. Because the others can be done mentally in a very short period of time. Of course, no one will have any difficulty saying 100 plus 25 is 125. Then reduce by 2 places of decimal. 125 reduced by 2 places of decimal, 1.25. And then we just divide 100 by 1.25 and the result is $80. We need to calculate the value of $1 EC in Trinidad and Tobago currency. And in order to do that, we will make a close inspection of the rate of exchange. $1 in Eastern Caribbean currency, we need the equivalent in Trinidad and Tobago dollars. So if we have here 0.40 and we need 1 because we are saying 1 EC. So if we need 1, any figure that we have and we want the equivalent of 1, then all we need to do is divide that number by itself. So in order to do that, we take advantage of how the rate is written on the EC side to find $1. Take advantage of how the rate is written. We will observe that on the EC side we have what? 0.40. So we will divide this 0.40 by 0.40 and we will get 1 on the EC side, and we will do the same on the Trinidad and Tobago side. On this side we get 1 because we are dividing a number by itself, and then the result will be the equivalent of 1 EC dollar. So the result on the Trinidad and Tobago side will be the equivalent of $1 in Eastern Caribbean currency. And that is what it is, $2.50. Also, in the other one, which is we need to find the equivalent of US $80. Take advantage of how the rate is given. And notice that we have $1 US right here. Therefore, in order to complete our calculation, we will multiply this by 80 and also multiply the other one by 80. So we have 1 on this side because the US has $1 on each side of the exchange rate. All we need to do is just multiply this by 80. We do the same on the other side and we have the equivalent of 80 US in Eastern Caribbean currency. So on the US side we have $1. To convert it to $80, all we need to do is multiply by 80. We will therefore do the same on the Eastern Caribbean side. And the result of the US $80 will be $216 in Eastern Caribbean currency. We need to calculate the value of $648 in Trinidad and Tobago currency, that equivalent in US dollars. There is no direct rate that links the two currencies. Let us therefore proceed in 2 steps. First, convert the Trinidad and Tobago currency to EC currency, then from EC to US, because there's a link here to there. That is our rate of exchange linking Trinidad and Tobago currency to Eastern Caribbean currency. So according to the rate because our first conversion is to convert that $648 in Trinidad and Tobago currency, convert that to Eastern Caribbean currency. Converting from TT to EC will therefore result in a smaller figure. This may be achieved by multiplying 648 by 0.4. Take a look at the rate. On this side, the number is smaller than the one that we have here. So in any conversion, when we are through, the number that we have on this side must always be smaller than the one that we have on this side. Or we may say the one on this side must be larger than the one that we have on this side, because of how the rate is given. Therefore, 648 times 0.4 is equal to $259.20. This result is the Eastern Caribbean equivalent of $648 in Trinidad and Tobago currency. But that's not enough. We need to then convert that to US dollars. So let us now make use of the rate that relates the Eastern Caribbean currency to the US currencies. There we have it. And we need to convert this in Eastern Caribbean currency to US. And notice also that the figure that we have on this side is larger than the one that we have on this side. Therefore, the figure that we will get for our answer should be smaller than this. According to the rate, the figure on the US side is smaller than that on the EC side. Converting from EC to US will therefore result in a smaller figure. This may be achieved by dividing 259.2 by 2.7, getting a smaller figure, and the result is $96, which of course is smaller. We have to be careful about attempting to multiply to get a large result or to divide in order to get a smaller result, as this depends on the figure in the rate. Remember that multiplying by a fraction that is less than 1 will result in a smaller figure, and dividing by such a fraction, the one that is less than 1, will result in a larger figure. So we do not just jump to multiply in order to get a larger result, or divide in order to get a smaller result. Dividing by a fraction that is less than 1 will result in a larger number. And of course, multiplying by a fraction that is less than 1 will result in a smaller figure. All of these things we need to be cognizant of while we are attempting to solve a problem. In this first part of problem number 2a, we will factorize that expression completely. And of course, we know that this is just two terms. It's not a difference of two squares because there's no subtraction sign. Therefore, we go straight ahead and use a method that is, of course, the fundamental principle of factorization, finding the common factor, then divide each term by the common factor. So the highest common factor here, we have 2, 6. So 2 is a common factor, x cubed, x squared. So x squared is a common factor. And of course, y is a common factor. So 2x squared y. Then each one of these terms will be divided by 2x squared y, as we have them right here. And here, the 2 will take care of each other. X squared into x cubed is x, and also the y's will take care of each other. 2 into 6 is 3. X squared divided by x squared, those take care of each other. Y into y squared is y. So there we have our answer. The common factor is 2x squared y and x plus 3y. It is not necessary to include the intermediate step in the examination. So the examiners imagine that we will just look at this, write down this as our answer, and that's all there is to it. The next expression to be factorized is in the form of a difference of two squares. It is required to be factorized at sight. Therefore, we should be able to just look at a difference of two squares and write down its factors. What approach do we take? We need to determine what 9x squared is the square of. So 9x squared is the square of what expression? The answer is 3x. When we square 3x, we get 9x squared. And that 3x will occupy the first positions in both pairs of brackets. Right there and there. 4 is the square of 2. This. So 2 will occupy the second position. And what will happen next? Place a negative sign in one bracket and a positive sign in the other. Order does not matter. That means we may put the positive here and the negative here, or vice versa. That's our answer. For the reason why we have progressed in this manner, consult Richard James Mathematics Resources, Volume 1, and that is Algebra, and topic number 4, which is Factorization. It is not necessary to include steps in the examinations that demonstrate the fundamental principles. It is only necessary to demonstrate that you can factorize it, which is factorize a difference of two squares. Some of my students even go as far as treating the expression as a quadratic, then factorize by grouping. But it is not necessary that they will go through all that process in order to factorize the difference of two squares. No matter how far you go, you will not get more than the marks that are allotted for it. And the marks that are allotted will be an indication of the number of steps that you need to take, and you will realize that it will not be many steps. The other expression that we have has 4 terms. For this expression, we may extend the first principle of factorization by including factorization by grouping, in which we factorize in pairs. And of course, the first principle of factorization is find the highest common factor of the terms, then divide each term by the highest common factor. And in the first 2 terms, the largest number that can go into 4 and 8 is 4. X squared and xy is x. And then we divide each one of those terms by 4x. Here we have also negative y as our common factor. And of course, we are making use of the signs. So we are maintaining our knowledge of directed numbers, and we are extending it to this process of factorization also. So there we have our highest common factor in the first case, and then 4x into 4x squared is x, and then 4x into 8xy is 2y. And we have here also our common factor of negative y. Negative y into negative xy. The y's will cancel, but negative into negative is positive. And negative into negative is positive also. Y into y squared is y. There's nothing to divide the two, and it goes back there. We will factorize a bit further by taking a common factor of x plus 2y. So the common factor in this particular case is x plus 2y. We'll take the common factor of x plus 2y and we will divide each term by x plus 2y. So we have there 4x, x plus 2y. The x plus 2y will divide into the x plus 2y and we have 4x. And x plus 2y divided by x plus 2y and we get y. So we have x plus 2y in one bracket and in the other bracket we have 4x minus y. And that's all there is to it. One make or break property of factorization that is evident in this particular problem is the handling of positive and negative signs. It is also worthy of note that the intermediate steps that contain the fractions are not necessary and are best omitted under examination conditions. That is, if we can always do it and get it right. They are only included here for clarity. Therefore, we are just including them for clarity, just to make our steps clear. But in examination, we do not need to include the steps that contain the fractions. Now we have what we call, some people call them simple. I hate to say that something is simple, especially when we know that it is a linear equation. So we will solve that linear equation and let us take a good look at the steps that we will take in getting it done. We will eliminate the denominators. It's always a very good step to take. When we have a linear equation, a very good step to take is always to eliminate the denominators. So we will eliminate the denominators of a fraction by multiplying by the common denominator, which is the LCM of the denominators. So eliminate the denominators by multiplying by their LCM. Multiply the entire equation by the LCM, which is 6, and see what happens. So we have 3 into 6 is 2, so we will multiply this part of the expression by 2. And also 2 into 6 is 3, so we multiply this part by 3. And later we'll take a closer look at it. Also, which is the part that most students tend to neglect, they'll just put the 3 here again, neglecting the fact that the entire equation need to be multiplied by 6. Therefore, 3 must be multiplied by 6 and the result is 18. We may now expand the brackets. They have no difficulty going ahead and expanding the brackets. And when we expand the brackets, we get minus 6 plus 15 minus 3x is equal to 18. So 4x minus 6 plus 15 minus 3x is equal to 18. Then we transpose the constants to the right hand side, and on the left hand side we combined the like terms. So combining like terms, 4x minus 3x will be there. Transpose this negative 6, positive 6. Transpose this positive 15, negative 15. So we have 4x minus 3x and all of this. 18 plus 6 minus 15. So 4x minus 3x is x. Then we have what? 18 plus 6 is 24 minus 15, and we get 9. So x is equal to 9, and that's all there is to it. On the next slide, we will demonstrate how the denominators are eliminated. Well, I imagine that the examiners would make it a little bit more spicy by putting a negative sign here instead of a positive. They do that quite often. So, well, I imagine that they can put a positive sign every now and again. So let us look at how the denominators are eliminated. Choosing to multiply by the LCM of the denominator is to ensure or ensuring that we have a single number that the denominators may divide into without leaving a remainder. So choosing the LCM, we have done two things. One, we have found a single number that both denominators can go into, and the second one is that we are also choosing the smallest such number for simplicity. Because if you put 12 or 18, it will still work, you'll still get the correct answer. But choosing the smallest such number will give terms that are simpler. As a consequence of multiplying each term in the entire equation by 6, the fractions will be multiplied by 6, and the number on the right hand side will also be multiplied by 6. There we have it. Everything multiplied by 6. So this 6 is multiplied there. This 6 is multiplied there. It's distributed throughout the equation. This 6 is multiplied there. And what do we know? We are making use of common factors here. So in the first fraction, we reduce by a common factor of 3. And in the second fraction, we are reducing by a common factor of 2. And no doubt, we maintain this. So 3 into 6 is 2, and 2 into 6 is 3. So we end up with our expression that we have on the previous slide. And also, we do not need to continue solving the equation because we have done so already on the previous slide. So the problem is already solved on the previous slide. We are only demonstrating how we eliminate the denominators in order to get those numbers multiplying those brackets. And there is our favorite, simultaneous equations. In solving this pair of simultaneous equations by elimination, we have to multiply both equations by a particular number in the usual fashion. It is better to eliminate the y's because of the difference in signs that will cause the resulting coefficients to be additive inverses. Therefore, manipulate the coefficients of y. And of course, we have said quite a bit right there. Now, we realize right here that we cannot avoid multiplying both equations by some number. So we'll have to multiply this equation by 2 and then this by 3. The x's will be eliminated. Also, the y's may be eliminated if we multiply this equation by 5 and this one by 2. But which one is better? I think that the second one is better. And it is better because when we multiply these, we are taking advantage of the fact that these two signs are different. And if they are different, then we have what we call, in the end, additive inverses when the values of the two numbers are the same and the signs are different. We'll have additive inverses. When you add them, the result is 0 and the y's will be eliminated. When you are manipulating positive and negative numbers, it is always easier to add rather than subtract. So first we multiply the first equation by 5. 5 3 is 15, 5 2 is 10, 5 10 is 50. Then we multiply the other equation by 2. 2 2 is 4, 2 5 is 10, 2 13 26. There. Additive inverses. So what do? Add the two equations. The coefficients of y are now additive inverses. The y's may be eliminated by adding the equations. So 15 plus 4, we have 19x right there, and 50 plus 26, 76. Eliminate the 19 by dividing both sides by 19. 19 is eliminated from the left hand side. On the right hand side we have 76 divided by 19, and that is equal to 4. And we will choose, maybe not the easier, but it is good if we choose the one that is easier. So this number 4, x is equal to 4, we will substitute that value into one of the other equations, and on this occasion we are choosing equation 2. So in equation 2, where we see x, we put 4. So 2 times 4 plus 5y is equal to 13. And what do we have? This 5y, this 2 4s, 8. 13 minus 8. So y, as a matter of fact, 5y is equal to 5. And y is equal to 1. So the solution is x is equal to 4, y is equal to 1. As in all cases, when solving a pair of simultaneous equations, we may eliminate either the x's or the y's. We should progress, making use of any loop of simplicity that exists. Whenever we are manipulating positive and negative numbers, it is always easier to add than to subtract. Making use of additive inverses when they exist or are easily created is usually simpler. So we have a Venn diagram already given to us, and in this particular case we are required to complete the Venn diagram first of all, and we are making use of information that is given to us in the statement of the problem. There we have the Z representing those who play neither volleyball nor tennis, and we are told that those that are in the Venn diagram but outside of the two sets are 4 in number. Therefore we will replace Z by 4. So those who play neither volleyball nor tennis, those are the ones that we are talking about, and the number of them is 4. So we will replace that Z by 4. Another bit of information: 30 students play tennis. In the set of those who play tennis, we already have 9x. Tennis. 9x is inside there, and we have 30 in all. Therefore, if we already have 9x and the total is 30, the remainder will be 30 minus 9x. So 30 students play tennis. In the set of those who play tennis, we already have 9x students. The rest of them will play tennis only. Y will therefore be replaced by 30 minus 9x. What do we do next? We are required to determine or write down an expression that represents the total number of students. An expression that represents the total number of students may be arrived at by finding the sum of all of the expressions in the different sections of the Venn diagram. So we have them highlighted there. All of them will be the x goes there, the 9x there, 30 minus 9x right there, and the 4. Those are all of them, and that is our expression for all of the students. Then what do? We are required to arrive at an equation and solve it in order to determine the value of x. For the equation, the former expression, which is the one that we have right here, will be equated to 36. But instead of just writing everything as it is right there, we may write a simplified version of it. And we may do that by making use of the fact that 9x minus 9x is equal to 0, and 30 plus 4 is equal to 34. So instead of having the 9x minus 9x again, we eliminate those. We have only the x and then 30 plus 4 is 34. Then we equate that to 36, and we will see that the answer is not very far away. X is equal to 36 minus 34, so X is equal to 2. That's exactly what we are about to do when we have 34 added to the left hand side. It is added to the left hand side. What do? We eliminate by subtracting 34. We do that from both sides. So subtract 34 from both sides. 34 will be eliminated on the left hand side, and on the right hand side we have 36 minus 34, and that is equal to 2. In this part of the problem, 3b, we are required to make use of the information that is given to us in the statement of the problem in completing the diagram. And we are told that Q is 15 kilometers south of P. The line segment that goes from P is in a southern direction. At the other end we have Q, and the distance is 15 kilometers. This is not rocket science. So this line that goes away from P is in a southern direction from P. And PQ is 15 kilometers. That's all there is to it. Also, in the statement of the problem, we know that R is to the west of Q, and it is 20 kilometers west of Q. That's all there is to it. And we have done that, which is completed the diagram, and we have included the points Q and R, and also the distances as required in the statement of the problem. Next, what do? We are attempting to find PR. But in attempting to find PR, some of my students paid too much attention to the shortest distance. They allow the shortest distance to get so much of their attention that they have to pause for a while. In the statement of the problem, the shortest distance is what kinda put a little fire on top of their heads unnecessarily. The shortest distance between 2 points is a straight line. All that we need to determine is the length of the straight line, PR. It may be determined by making use of Pythagoras theorem, because we have two sides of a right angled triangle and we need to find the other. So when they say the shortest distance, they just mean in a straight line from P to R, which is what will complete the triangle, and we need to find the distance PR. Also, my students are aware that the most popular right angled triangle has its sides in the ratio 3 to 4 to 5. Therefore, they should be able to just look at this particular triangle and realize that this is such a one, and be able to determine without a single stroke of the pen that 15 and 20 are in the ratio 3 to 4. So all we need is the side 5, because the ratio is 3 to 4 to 5. The missing side, which is the hypotenuse and the longest, should complete the ratio and must be 25 kilometers. So we have 3 to 4 and we need 5. Of course, no difficulty seeing that 15 and 20 are in the ratio 3 to 4, because a common factor of 5, 3, a common factor of 5, 4. Therefore we need the other one, which is the 5, and we know that is 25, and we may just write that answer down. No, we cannot do that. We are required to show some steps, like what we have there, applying Pythagoras theorem. 15 squared plus 20 squared, the square root of all of that, this is what we are attempting to find, because all we are attempting to find is the hypotenuse of that right angled triangle. So PR is equal to the square root of 625, and that is equal to 25. All of the numbers are very sweet. We know that 15 squared is 225. We don't need a calculator. 20 squared is 400. Put them together, we get 625. And everybody knows that the square root of 625 is 25. If not so directly, that 625 is the square of 25. So there's really no difficulty to it. But as I said before, we should be able to make use of the fact that this triangle is actually a 3, 4, 5 triangle. The other part of the problem requires that we find the angle that is located at P, which is QPR. My students are also aware that the two acute angles in the 3, 4, 5 right angle triangle are 37 degrees and 53 degrees. With the angle QPR being opposite to the longer side, it is the larger angle and is therefore 53 degrees. So this angle has to be 53 degrees because it is the larger of the two. The larger, that means the larger is opposite to the longer side. So in a triangle, the longest side is opposite to the longest angle, and the shortest side is opposite to the shortest angle, and so on. So we are sure that this angle is 53 degrees. Knowing what the answers are is one thing, and being able to find them is another. Let us apply a bit of trigonometry in which we will make use of the two sides that were given to us. Remember that in mathematics we should not use a previously calculated value unless we have to. So we will find this angle making use of these two sides. We could have made use of the 25 kilometers also, but we should not make use of a previously calculated value unless otherwise stated. So the angle that we are attempting to find is this one. So what do we know? Relative to the angle that we need to find, this side is the opposite and this one is adjacent. The trig ratio that has opposite and adjacent is tangent, and it is not only important to know that opposite and adjacent implies tangent, but that tangent is equal to opposite over adjacent. After that, we make the substitution into that equation, substituting the opposite to 20 and the adjacent is 15. That is approximately 1.33 recurring. And in order to find the angle whose tangent is 1.33, we will find the tan inverse of 1.33, and that gives us an answer of 53 degrees as we imagined at first. And also the answer was required to be given to the nearest degree. The length of the arc ABC is a fraction of the circumference, because in this particular case we are required to find the length of the arc ABC. In a circle, the length of the arc is a fraction of the circumference of the circle, and the angle associated with this arc is not this one but the other one, and the other one is the remainder of 360 degrees when we subtract 90 degrees. The fraction of the circumference is therefore the angle associated with the arc over the angle of an entire revolution, which is what we have right there. And what is this? This is the formula for the circumference of the circle. So the arc is related to the circumference of the circle, and to find the length of the arc, we make use of the associated fraction. And in this particular case, the fraction is the associated angle of 270 degrees that is placed over 360 degrees multiplied by 2, multiplied by pi, and then multiplied by r. And the result is 16.5 centimeters. To complete the perimeter, we need to also include the sides OA and OC, because we have here, and the perimeter is completed by this and by this. And each one of these is equal to the radius of the circle. So we may include 2 radii of the circle in order to complete the perimeter. And the result is 23.5 centimeters. After the perimeter, we need to find the area of the sector. Finding the area of the sector is analogous to finding the length of the arc, to the extent that the fraction that the sector represents is equal to the fraction that the length of the arc represents. So the fractions are the same. So the fraction associated with this sector is still 270 over 360. What is different? What is different? The area. So the area is pi r squared, and the angle is the associated angle over 360. Turns out to be 270 again, because it is an associated sector in association to the arc that we have just calculated the length of. And the result is 28.875 centimeters squared. Why didn't we round that off? Well, I chose not to round it off because it is a finite fraction. It is not like a recurring decimal, or maybe something that is the result of an irrational number. Since the fraction, the decimal fraction, is a finite decimal, I will not bother to round it off. Now we are required to find the volume of the prism, and the volume of the prism is equal to the product of the cross-sectional area and its length. We have calculated its cross-sectional area on the previous slide, and its length is 20 centimeters. So in order to find the volume of the prism, we take the cross-sectional area and multiply that by the length. But we have calculated the cross-sectional area on a previous slide, so we'll just multiply that by the length. Cross-sectional area times the length, the area from the next slide, previous slide, and then multiply that by 20, and the result is 577.5 centimeters cubed. Next, we need to determine the mass if we are given certain additional information like we have right here. 1 centimeter cube of the tin has a mass of 7.3. This is equivalent to saying that the metal has a density of 7.3 kilogram per centimeter cube. Density is equal to mass over volume. By transposition, mass is equal to density multiplied by volume. So mass is equal to density multiplied by volume. We take the density, which is this, and we multiply by the volume, which is this, and we will find the mass. So the mass is 4,216 kilograms. Let us take a second look at the formula for density. Density is equal to mass over volume. We are dividing by volume here. We are dividing by volume here. So we will transpose the formula by the density multiplied by the volume is equal to mass, then we may reverse the equation. Mass is equal to density multiplied by volume. Here we are required to construct by making use of a ruler and a pencil and a pair of compasses. That is what we need to do. Make use of only ruler, pencil and a pair of compasses, and we are required to construct a triangle. First, we will draw the line PQ is equal to 8 centimeters. So with the aid of the ruler, draw a line 8 centimeters long as shown, and that will be represented by PQ. Draw that line with your pencil and your ruler to 8 centimeters. After that, what is required? QPR is equal to 45 degrees. We need to construct that 45 degrees by placing that angle eventually at P. So P is where the angle will be located. QPR is 45 degrees and is located at the middle letter. The middle letter is P. So let us therefore construct that angle at P. The process will not be carried out, only the constructs will be shown. And that's quite a bit. In order to construct that 45 degrees angle, we have right here first what construct is this? That is the first construct, a 90 degrees angle at P. Then we bisect that 90 degrees angle that is at P, and a line that goes right here through the part of the construction which is the bisection, which is bisecting the angle. So if we have this 90 degrees angle, bisecting that angle, we will get 45 degrees. So we need to draw a line that goes like that. Draw a reasonably long line through the final pair of arcs. While so doing, it should be taken into consideration that the line that completes the 60 degrees angle should be able to intersect it. Remember now, we are about to construct a 60 degrees angle. Now, the length of this line was not given, and the length of the line that will be constructed at the 60 degrees angle was not given. Therefore, it is important to draw this first line sufficiently long that when we attempt to draw the line that goes from here 60 degrees to this line there, that line will actually cross this. Now, in the end, if it does not cross, all we will need to do is increase the length of this line. But in order that we do not do something and then have to go to do it a second time, it is best to draw it reasonably long. The other angle PQR is equal to 60 degrees, and it will be located at the vertex of its middle letter, so it will be located at Q. We may also take advantage of the fact that it is the only other available point. Again, only the construction arcs will be shown. So we are constructing a 60 degrees angle there. There we have the construction arcs. And then what do? Draw the line QR to meet the 45 degrees line. So this is the 45 degrees line that we are talking about. And we need to draw the line like that. This time we do not have to make it into a pale construction line, because this line is already fixed. We know that it will go through the intersection of those two arcs to meet the other line, and as long as we do that, then we are correct. We do not have to draw it like a construction line. The reason why we did this as a construction line is to ensure that at the end we do not have to make too much adjustment and have to erase a line that is bright. As a matter of fact, we can see it right here, that in the attempt to make it in such a way that we do not have to draw it a second time, we did it long enough, and of course this part remains. So that is why it is necessary. Then we may complete the triangle by placing the line with the correct intensity at PR. Measure RQ and state its length. That is what we need to do next. Measure RQ. And there we take our ruler and measure RQ. And what we have right there is approximately 5.9 centimeters. For details of the constructions of the 45 degrees and the 60 degrees angle, consult Richard James Mathematics Resources, Volume 5. And Volume 5 is Computations Part 2 and Geometry. The topic is number 21, that is construction. Discussing the details here will be too time consuming. Number 5B. Number 5B is a pretty straightforward problem, but I appreciate the existence of such a problem on the examination paper, as we will see in a short while. First, we need to find the gradient, and find the gradient making use of that formula. And it does not matter which one of these 2 points is x1, y1 or x2, y2. And also it does not matter if we say y2 minus y1 over x2 minus x1, or the other way around, y1 minus y2, as long as when we get here we say x1 minus x2. The order does matter. We cannot have them crisscross. So they should be vertically aligned. The 2's will be vertically aligned and the 1's vertically aligned. And if we put the 1's here and the 1's are vertically aligned, nice. The 2's are vertically aligned. Nicer. So we have negative 2 minus 6 over 0 minus 6. We have negative 8 over negative 6. And we may reduce by a common factor of 2. And do not forget that negative divided by negative is positive. And even without seeing the 4 over 3, I could have already seen that it is a 3, 4, 5 right angle triangle already. Therefore, when we are asked to determine the length of the segment, we know that it is in the ratio 3 to 4 to 5 again. So 6 is the 3, 8 is the 4, and then 10 will be the 5, in a matter of speaking. So we know that the length of the segment will be 10 units, because this is another occurrence of the 3, 4, 5 right angle triangle. We have the gradient, and the point T is the y-intercept, because its x-ordinate is equal to 0. Now, the examiners expect that students will do this, and students generally approach problems blindly. Not every single one of them will do that. Now, some may use a formula, y minus the value of y1 is equal to gradient times all of x minus x1. Or they may use their favorite, y is equal to mx plus c. But the problem is that all of that is already simplified, because this point T is the y-intercept. And the equation of a straight line is what? Y is equal to mx plus c. Good. And m is what? 4 over 3. And c is negative 2. This point is the y-intercept because the x value, x-ordinate, is equal to 0. It is located on the y-axis and is actually where the line crosses the y-axis. So we do not need to go through y minus y1 is equal to gradient x minus x1, or to say y is equal to mx plus c, and then substitute in some values in there, then find the value of c, then put that into the equation. All we need to do is what? 4 over 3 is the gradient and the intercept is 2. We can just write that down in one step. Next, our favorite, the midpoint. And the midpoint is the average of the two ordinates. 6 plus 0 divided by 2, 6 plus negative 2 divided by 2. That's all there is to it. The average of the ordinates. Add the x's, divide by 2. Add the y's, divide by 2. There's nothing to it. 6 plus 0 is 6 divided by 2 is 3. And 6 plus negative 2 is 4 divided by 2 is 2. 3, 2. And the one that we know the answer for already. The length of the segment ST is what we need to find. And that is the formula for your length of segment. Substituting the values, we have what? 6 minus 0 is 6. 6 minus negative 2 is 8. So the square root of 6 squared plus 8 squared. And on top of that, we know that square 6 is 36, square 8 is 64. Add them together, we get 100. Find the square root of that, and it's 10 units. I told you long ago that such is the case. Great that the examiners are testing a knowledge of the basic concepts associated with the equation of a straight line. Too often students demonstrate ignorance or amnesia in this very important topic. Sometimes you ask the students to find the length of a line and they start to act as if you're asking them to do something that is impossible. All because they have taken these things for granted. Because I'm sure, like I've done, all other teachers would have taught them these basic principles associated with the equation of a straight line. But when we are required to use them, the students act as if they have never seen them before. So it is a very good thing that this one is present on the examination. And I was a little bit alarmed to realize that Shane Hacker did not do it in the exam. He left it and then to return and did not have enough time. Well, I imagine that he would have completed a lot of other problems that will cause the omission of this particular problem, when it is not insignificant to have the minimum negative effect. The first part of this problem, what are we required to do? Locate the center of enlargement. To find the center of enlargement, extend lines that join points to their images. So we have a point is this one and its images are, so join the point to its image and extend that line. We may use this one, L to the image of L, which is P, and extend the line until they cross. Where they cross, that's your center of enlargement. And we did a problem like this in the same week of the examination. We were doing tutorials, and a problem like this one was a part of it. I don't remember what paper it's on, but my students would have remembered that from 2 or 3 days before. Write down the coordinates of the center of enlargement. 1, 5. For a scale factor, compare the length of a side and its image. So the length of the side that we have here is 1, 2, 3 units, and its image is 1, 2, 3, 4, 5, 6 units. So the original is 3 units and the image is 6 units. What is the scale factor equal to? The length of the image divided by the length of the original. 6 divided by 3, and that is equal to 2, and the scale factor is 2. What do we need for part C? as discussed in some detail on another practice paper, the areas of a triangle and its image under a size transformation are related to each other by the square of the scale factor. Therefore, the scale factor in this particular case is 2. Therefore, this is an enlargement of this by scale factor 2. Therefore, this area is 4 times this one, because 4 is the square of 2. So the area of PQR over the area of the other one, which is the original, is equal to the square of the scale factor, which is equal to 2 squared, and that is equal to 4. But I kind of like the way that the problem was stated in the examination, leaving room for flexibility. Therefore, it was not far-fetched or hidden that the student should be able to find the area of this one. The area of this one is 1, 2, 3 by 2. Half of 2 is 1. 1 multiplied by 3 is 3. This one, we have 6 by 1, 2, 3, 4. Half of 4 is 2. Right. So 2 sixes. So half of 4 is 2. 2 sixes. 12. So the result would have been 12. So 12 here and 3 there. 12 divided by 3 is equal to 4. So the students or the candidates could have chosen to use the actual areas in order to determine the answer. Also, the grid allows the area to be calculated quite easily. Candidates may choose to go that route. Of course, our next step is to draw a triangle whose coordinates are given. Well, the coordinates of the vertices. So A is equal to negative 4, 4. So we negative 4 in the x direction, 4 in the positive y direction, and the point is located right there. Then the other point, B, is negative 1, 2. Negative 1 in the x direction and 2 in the positive y direction right there. And finally, we have C, negative 1 in the x direction and 4 in the positive y direction, and it is located right there. And what do we do? Nothing else but complete the triangle as required in the statement of the problem. Next, we are required to give a complete description of the transformation that maps this triangle onto this one. Candidates should be able to just look at the figure and figure out the transformation. However, we may use a process of elimination in arriving at our answer. So some students should just be able to just look and tell that this is a rotation, because in a reflection they understand the mirror effect of having the thing laterally inverted in such a way that there is a line of symmetry. That one, they know that is not a reflection, because we do not have a line of symmetry that we can construct in order to have these two figures, this one and this one, being symmetrical about that line. So this is not a reflection. But let us go through the details as we have them. It is not a translation, because all points do not move in the same direction. So we have, take a look at this now. This one, A, is the one that goes from L in that direction. C is the one that goes from M. Notice the direction, like that. So they do not move in the same direction, so it is not a translation. With no change in size, the transformation is not a size transformation. There is no change in size, so we do not have a size transformation. the image is not a lateral inversion, as we discussed before, of the object as we would expect in the case of a reflection. Furthermore, there is no line of symmetry between the object and its image. So that is not a reflection. There is no obvious mirror line. Therefore, the transformation has to be a rotation, which is the only one that is left. The center is at the single point from which a point and its image are equal distance. And we may just be able to just take a look at it and tell, but we can just do a little bit more detail to see that B, which is the image of this one, N, that the distance here could be the same, because the distance is actually 1 by 2 units, and this is 2 by 1. It does not matter. It is 1, 2, or 2, 1. Also, C and M, this is 4, 1. This is 1, 4. So the distance will be the same. And also, we imagine that the same will be true. 4, 4 for the L, and 4, 4. So each is equal distance from this point, and this point will turn out to be the center of rotation. So the center is the origin, 0, 0. A detailed discussion of a similar problem was done on a previous practice paper, and we may be able to go to that practice paper in order to get some more information on it. So for the angle of rotation, draw lines from the center to points and their images. So this is the center, and we have L and its image A, and we have drawn those lines, and then the angle of rotation or turn is a right angle, and that is 90 degrees, and this is the angle that we are talking about right there. The direction of rotation is anti-clockwise, going in the opposite direction to the hand of a clock. Anti-clockwise, like so. The statement of the problem required that the transformation be fully described. The transformation is an anti-clockwise rotation of 90 degrees about the origin. And it is important to give certain details, and I'm not just going to do it for rotation only, which is the correct one, but we are doing that for the other transformation. For a size transformation, a full description should include the center and the scale factor. Cannot leave that out. For a translation, a full description should include the vector of translation. For a reflection, a full description should include the mirror line. And for a rotation, a full description should include the size of the angle, the direction of turn, and the center of rotation. We have data, and we need to first complete the cumulative frequency column. Completing the cumulative frequency column is a matter of accumulating the frequencies as we traverse the frequency column downwards. Therefore, to the present value of the cumulative frequency, we will add the next value in the frequency column. As shown, we are accumulating the frequency as we go down the table. Therefore, as we go down the table, we will add the present value of cumulative frequency to the next value of the frequency, and that is 15 plus 20 is equal to 35. Then we take, this will now be the present value of cumulative frequency, and we add that to the next value in the frequency column, and that will give us there we have our 47, and we do not go any further because, as a matter of fact, we have the final item in that cumulative frequency column. Next, we are required to draw the cumulative frequency curve, and it is done by plotting cumulative frequency against the upper boundaries of the class interval. And what do we have there? The upper limits. Recall and make use of the fact that the upper boundaries of the class intervals are always a half of a unit greater than their respective upper class limits. So, in drawing the cumulative frequency curve, we will not use these. These are the limits. We will use the upper class boundaries, and we will do that against the cumulative frequency as we will demonstrate. Notice that we did not indicate a breaking of the axis here, which should have been appropriate. Was not done because in the examination it is not a requirement for sure, although the first point is located some distance away from 0, which is of course 49.5 units away. So we did not break the axis because it was not necessary. In landscape or portrait, the thing could have been arranged on the grid without having to break any axis. But for this particular case that we are demonstrating the computer generated curve, well, not computer generated, as a matter of fact I actually create every single thing that we have right here, but in order that we might have a diagram that is quite friendly to the eye, we started at 40 without breaking the axis. So let us plot the graph. So we have 49.5 going up to 4. So about that, and we go up to 4 and the point goes there. Then we have 59.5 going up to 15. About there, and we go up to there. $69.5 going up to 35. $79.5 going up to 47, and 89.5 going up to 50, and that completes it. So let us put the cumulative frequency curve, draw that curve smoothly going through all of these points, and it cannot end there. So what do? The curve cannot be left hanging. It has to touch the axis where the upper class boundary of the class that is previous to the first would have been. So we have 89.5, 79.5, 69.5, 59.5, 49.5, 39.5 will be the next one, as we have the sequence right there. So look at the sequence, and we are going down 69.5 to 59.5, then 49.5. The one before that will be 39.5, and there is where the curve will touch the axis at 39.5. Then we may proceed to draw the smooth curve that passes through all of those points. The median is the middle score and is associated with a half of the total cumulative frequency. So the median is the middle. To find that median, we go half of the total cumulative frequency. Let's do that. So draw a horizontal line from 25 on the cumulative frequency axis to meet the curve. As we have the information here, the median is the middle score and is associated with a half of the total cumulative frequency. A half, the total of the cumulative frequency is 50. So a half of 50 is 25. The median is not 25, but it is associated with 25 on the cumulative frequency axis. So we will go to 25 on the cumulative frequency axis and draw a horizontal line to meet the curve. What do we do next? Where the line meets the curve, draw a vertical line to meet the horizontal axis. And then that is the median and the median age. Where the vertical line meets the age axis, we find the value of the median age. So the median is equal to about 64.5 years. That is the value that we obtain from this curve. The value that I obtained from the curve that I did on graph paper is somewhat different, but in the examination we are expected to write down the value that we arrive at from our curve. Next, we need to find a particular probability. So we need to find the probability that a person is 75 years or younger, and we will do that by first finding the number of persons that are 75 years or younger. Draw a vertical line where age is equal to 75 to meet the curve. That is our first step in doing that. We need to find the probability that a person is 75 years or younger. But before we can do that, we need to find the number of persons that are 75 years or younger. Therefore, we go to 75 years on the years axis. Draw a vertical line to meet the curve. Then, no doubt, draw a horizontal line to meet the cumulative frequency axis. That will be the cumulative frequency of interest. There. Therefore, we are taking ages that are less than or equal to 75 years. And the region of interest will be from 0 to 42, as we have it right there. That region is 0 to 42. 0 to 42. And that represents the number of persons that are 75 years or less. The probability is equal to the number divided by the total cumulative frequency, and that is equal to 42 over 50, because 42 individuals are 75 years old or younger, and that we divide by the total number of persons in the survey.